Equations in two variables. An equation in two variables is something that involves an x and a y, an independent and a dependent variable. And the equation is set up so that the y values depend on what the x value is in the input. So for example, y equals 3x minus 2. This is an equation with two variables, right? Okay? The y value depends on what the x value is. So the y value is called the dependent variable, and the x value is called the independent variable. Alright? Those are just more terms, if you will. A solution to an equation is an ordered pair that satisfies the equation. I hope somebody could give me a solution to this equation.
Do you want us to?
Yeah, somebody?
1 and 1?
1 comma 1. I think that works. Would you guys agree?
Yeah.
If you plug it in, does it work?
Yep.
Plug a 1 in for y, a 1 in for x. Are they equal? Give me another one. Just pick any number, plug it in for x, see what you get for y. Marshall.
9 and 7.
9. Careful.
Oh wait, no. No. 3.
That's-
3 comma 7, right? 3 comma 7 would be a solution. Plug in 3 for x, you'll get 7 for y. It works. Jake?
2 comma 4.
2 comma 4. Good. How many solutions are there? A lot. Infinite. What if I want you to represent every solution? Graph it. You know what a graph is? A graph is a set of every solution to a system with two variables. That's what a graph is. It's a set of all ordered pairs that are solutions to some equation. Set the calendar wall. A graph is the set of all ordered pairs that are a solution to the equation. So if I wanted you to graph or represent all the solutions to this equation, I want you to draw the graph. Hopefully you remember how to graph it. Y equals 3x minus 2. That is in slope-intercept form. What is your slope? 3. What is your y-intercept?
2.
Negative 2. So how do you graph it? Go down to negative 2. Here's your y-intercept.
Go up 3, go over 1.
Rise 3, run 1. Rise 3, run 1. Rise 3, run 1. Okay? Or down 3, left 1.
Down 3, backpedal 1.
Okay? Yeah.
Fall 3.
Plot enough points, get out a ruler, or just be very accurate, or try to. Okay? Sorry, that's not great.
It's beautiful.
Alright? Try and do a pretty good job on yours, especially on a test. Okay? It's a lot easier on small paper than it is up here, believe me. Okay? Without a ruler, that is. Ruler would help. Put arrows on the ends. But every single point, guys, every single coordinate on that line, every single one of those would satisfy or would be a solution to this equation. That's what a graph is. A graph is something that consists of every possible solution to an equation. Okay? Questions on that? Let's see. What we just got done graphing was a linear function. Why was it a linear function? It was a line, yeah. Okay? Usually written in the y equals mx plus b form, where m is the slope and b is the y-intercept. We talked about that. That hopefully is review. If not, you can jot it down or copy these notes later too, and you have more time. Can somebody give me a function that is not a linear function?
Y equals x squared plus whatever.
Great, y equals x squared plus 3. That's not a linear function. Anybody know what it's called?
Exponential. No, parabola.
The graph would be a parabola, and it's called a quadratic function. Okay, not an exponential function. You've had exponential functions before. That's when your x is up in the power, like y equals 3 raised to the x power. That's an exponential function. Okay, but it's a quadratic function. Y equals x squared, the graph would be a parabola. Yep. Anything where there's a power is not a line anymore. Okay? And then function notation. Sometimes you see f of x equals instead of y equals. Understand that's really no different. It's just a different type of notation that we use when we're representing functions. The reason we do that is because later on we start using multiple functions in the same problem. And you can't have y equals this and y equals this, all right? Y can't equal two completely different things. So we write f of x equals this, or g of x equals this, or h of x equals this. Okay?
Come on, wrestler.
That's not my concern.
Here's what I'd be expecting of you. Be able to do. Given the function, f of x equals 2x squared minus 3x plus 7. By the way, is this a linear function?
No.
Nope, it's a quadratic function. It's got an x squared in it. Find the following. It says f of negative 3. What does that mean to do?
Plug in negative.
Plug in negative 3 for x. Okay, here's how I'd want you to write this. Okay, you might want to jot this down. I'll give you definitely time for this. F of negative 3 equals 2 times negative 3 squared minus 3 times negative 3 plus 7. Do you have to show this one? No. But if all I see is the wrong answer, it's kind of hard for me to know what you know if I don't see any work. Negative 3 squared is 9. 9 times 2 is 18. Minus 3 times negative 3 would become what? Plus 9, plus 7. So my final answer, f of negative 3 equals how much?
34.
36.
34, I believe, right? Yes.
Freshman showing.
Okay.
Yeah.
There we go.
You probably gave him some hand signals, some of that.
Okay. F of negative 3 equals 34. Okay? Don't solve for f. F is not a variable. F is simply the name of the function, okay? And this is saying, pay close attention if this has always confused you. This is saying, when I plug negative 3 into the function f, out came a 34. Basically what this just is an ordered pair. It's an x value and a y value. It's saying when I plugged in negative 3 for x, out came a 34 for y. That's really what that's telling you. Okay? F of 0, you should be able to do that in your head. What's f of 0 going to equal?
0.
Careful.
7.
2 times 0 squared minus 3 times 0 plus 7.
7.
Be 7. F of 0 would equal 7, right? Follow that? Okay? Don't let this confuse you. It's actually pretty easy. F of m would equal what?
2m squared.
2m squared
Plus
minus
Minus
3m
plus 7.
plus 7. Can you do anything more with it?
No.
Nope. That's it. It just told you to plug m in for the variable. So you get 2m squared minus 3m plus 7. And do a little mental math there at the end, guys. F of 4. What will f of 4 equal? Get out of the way. F of 4. What would that equal?
27.
27s. Squared. 16, 32. Minus 12. 20 plus 7. 27. Alright? Questions on that? Alright, homework, page 77 to 78, number 5, 9 through 29 odd, 35 and 39 odd, 43 and 45. Okay? All odd, my expectations is that would be done, okay, when you come to class tomorrow, because we're just jumping right ahead to the next learning target tomorrow. Okay, this is all review. You should be capable of doing this, but you need to put some time in and actually do it.